Hello everyone. Good evening, good morning, wherever you are. At present, it is about 10:44 here in India. So roughly, we are edging close towards the 11 p.m. mark. So let us continue with where we have left before, and we were discussing HANA administration. That is, we were discussing the S4 HANA architecture was yet to be discussed. We were discussing the HANA architecture. So rather than putting SAP Press Book on HANA administration and S4 HANA. Okay, I have these books open so that it will take minimal time for us to go ahead with it. Please bear with me because today's concept is very important. So let us try to get the best out of it. We'll start with HANA architecture as we see here. The HANA Studio look and feel. Okay. I don't think this had that here. TCTU architecture. I believe not this book, some other book. No, this book only. Architecture, correct. We got it. Good. So we started our discussions from here and we were comparing this with the other book, which is the SAP Press book. So let me take you there. Mm, Along with that, we will refer some more books today. But the topic will be same: HANA architecture and S4 HANA architecture. Then we will learn what are the uh, common things in that and what are the additions that we are getting in S4 HANA architecture. So this book basically Intelligent ERP, S4 HANA Intelligent ERP. So it talks a bit on HANA. So this is needed S4 HANA I mean. And this book has SAP S4 HANA architecture. Okay, we have the we have to open the trainer document. What is this? Continuous delivery. This is fine. Continuous delivery for SAP HANA Cloud. Okay, this will require later. Let us go to the activity trainers data. Trainers data. Yes, this was our draft book where we were capturing everything, and we ended up with elaborating these three diagrams, which is not completely elaborated. We just scratched the surface. Today we will go inside it. Okay. So S4 HANA Intelligent ERP, S4 HANA Architecture, S4 HANA, S4 HANA Introduction, Introduction. No, this is not required. Migrating to this two we can park for later. We can close this two for now. SAP S4 HANA Cloud. Okay, we'll keep it for some time. SAP S4 HANA, what it is. And this is administration tool, HANA 2.0 administration, Git, technical architecture foundation. And this is a very good book which I will touch upon, the future of basis administrator. Before that, we will first dig into, I was telling you, peeling the surface of the onion one by one. That's the way we go to the core of it. So this book's approach is also the same. So why don't we go to the HANA, this one, architecture of SAP HANA database. Okay, fine. Okay, we'll start the reading from here. Okay, the SAP HANA system contains many components that the administrator need to understand, which you will learn all. Okay, so it contains many components. The highlighted is not there, is it? Okay, never mind. We will just focus on this HANA architecture physical view. So what we are going to see, the physical view, then the operating system view, then the logical view, then distributed HANA system, appliance concept of SAP HANA, release cycles. Release cycles, support pack stack, primary database, installation update, administration tool, scale out high availability we thought of touching, but first the architecture. Okay, we were putting everything, we were dumping it in the Word document. Star dot doc x docx SAP scenario SAP project manager, coupon SAP cutover and hyper. Okay, let us take this for example. SAP HANA architecture. SAP HANA system contains many components that we as SAP system admin we need to know. For the interaction of end user and developers to SAP HANA system, only two are visible. The database system fulfilling the famous, this I discussed in the previous video, acid principle like atomicity, consistency, isolation, and durability. So this we had already discussed. And the development platform access server that we discussed. This is a highly simplified architectural overview of SAP HANA system. Architectural overview of SAP HANA. The two main components described in the previous paragraph, which is by bringing application development. So by bringing application development and data storage more closely together than the previous SAP systems. Okay. So if you see this diagram, what does this say? By bringing application development and data storage more closely together. So if we go here and we focus on the diagram, this one, as I was telling you, these are client applications, that is either from a NetWeaver web interface, web browser, or NetWeaver web browser, other SQL client. Three input points. So if it is NetWeaver, locally deployed, example BW or ECC, standard NetWeaver platform on top of which ECC is there. So if the end user tries logging in through that, he will pass on his SQL query into the HANA system, which has both the database server, index server, and the development platform XS server. XS follows the development in Sybase. So XS get a input from the HANA Studio. Okay, HANA Studio installation is required. HANA client installation is required. Then on top of that, HANA Studio installation. So from this HANA Studio, this input is coming in the form of a, wait a second, this HTTP, this is tracking this path. Let me take the pointer. Pointer option, there's a pointer. Web browser application for admin development. This one, from here it is going the HTTP request and going to the XS server. That is one connection. Another is from the HANA Studio. It is the request that, I mean, the flow of information to the HANA system is through SQL and it goes to the index server. The data flow for external source. This data flow we have understood. That is from web browser, it will go via HTTP request to XS server, which is development server, and HANA Studio. From here, it will go to via the SQL. The SQL request will enter the index server, and below it there are further components which they will elaborate. And the data flow from external sources is SLT, real-time data, SAP data services. Data goes on batch jobs, batches, other data provisioning. This is that data flow. So this is a bit more elaborate diagram on the right side. So over here we see HANA appliance constituting HANA database, which will have index server, preprocessor, name server, statistics server, and access engine. So that diagram here, this is only index servers inside is captured over here. So first we explain this two, then we will go deep into the other part. Okay. So let us read it a bit. SAP HANA system contains many components. which we as administrator we need to know. However, for interaction of end user, the developers in SAP end user and developers in SAP HANA system. Here the developer they are talking about who are using XS server. So only two are visible. There are only uh, two components is visible, which you will that is only two are visible. The relational database system fulfilling the ACID requirements, which is atomicity, consistency, isolation, and durability. The SAP HANA system only uh, has got many components, but here only two are visible. The relational database system fulfilling ACID, which is atomicity, consistency, isolation, and durability. Granular in nature, atomicity, consistency, isolation, and durability. So, if we try to understand what exactly this line means, why don't we take the help of AI a bit? Let us go to ChatGPT and let us try to read. SAP HANA system only contains many components. So if we take this, copy this part, yes, it's getting copied. So uh, interaction of end users and developers in, however, for the interaction of end user developer in the HANA system, only two components are visible: the relational database system fulfilling famous ACID requirements, and the development platform and application server within the same environment. This we are understanding from the diagram. Access and index server are both there. So if I write ChatGPT, can you explain uh, the following right up below and summarize it in 25 words, or let's say 30 words, and let us put that request. SAP HANA system consists of multiple components, but only two are directly visible by the end users and developers. One is relational database system, which ensures the integrity of following ACID principle, which is atomicity, consistency, isolation, and durability, and development platform and application server provides an environment for building and running applications within S4 HANA. So basically, this thing, the XS server, which is here, and if we come here, the SAP HANA system consists of multiple components, but only two are directly visible to the end user and developers. Only these two, index server and access server, is visible. So one is the relational database, which ensures data integrity following the ACID principle. So ACID principle, if we just elaborate what is ACID principle, we can say what is ACID principles, what is ACID principles can you elaborate? ACID stands for atomicity, consistency, isolation, and durability. Four keys properties that ensure reliable and error-free database transaction. Error-free database transaction. So this follows ACID principle. So atomicity, the transaction is atomic, meaning it is treated as a single unit of work. Atoms, the tiniest most element. So you take atom, so it meaning that it is treated as a single unit of work. If any part of transaction fails, the entire transaction is rolled back. Nothing is saved. So in RAM, if there is a failure, entire thing will roll back. Nothing would be saved. So example, a bank transfer consists of debiting one account and crediting other. Simple example. If the credit step fails, that is when paying the when the money is going out, right, to the consumer, to the customer. If the credit step fails, the debit step must also be undone to maintain the accuracy. Is that is like from one bank account you are mm, taking money, you are in one bank account you are depositing money, and that same money you are withdrawing out, let's say, on the and during this process of transaction, if one fails, then the other will also fail. If the bank transfer consists of debiting one account and crediting another, so actually two accounts of the same individual or different individual, let's say two accounts of the same individual to make it keep it simpler. So bank transfer consists of debiting one account and crediting another, two accounts. If the credit step fails, the debit step must also be undone to maintain accuracy, so that there will not be any wrong data. Both the side uh, will come to the balance. So this we are understanding the concept credit and debit in bank. So what does atomicity do? A transaction, if transaction is atomic, meaning it is treated as a single unit of work. If any part of the transaction fails, the entire transaction is rolled back. That is atomicity. Consistency is data integrity. The database must contain a valid state before and after transaction. Data integrity. Transactions should always follow defined rules, constraints, and relationship to prevent data corruption. So it should have defined rules, constraints, relationship to prevent data corruption. Data should not go bad inside. So if transaction violates a foreign key constraint, example, there is primary key, foreign key. Example, trying to assign an order to a non-existent customer. The customer is not there, non-existent. The transaction is aborted. It will find that the person to whom they are going to assign the purchase order or things, that account is wrong. That is a non-existent customer. At that time, the transaction will be aborted, it will not go further inside. So atomicity understood, consistency understood, isolation. Multiple transactions can occur simultaneously, but they must not interfere with each other. The final result should be in same as transactions were executed sequentially. The final result should be the same as if the transaction were executed sequentially. It will do so fast we will not be able to understand what is happening. But what it is saying is multiple transactions can occur simultaneously. Yes, it can go one after, it can go all together, multiple transaction, but they must not interfere with each other. Like one going, another transaction, two should not interfere with each other, and the final result should be same as if all transactions was executed sequentially. Should feel that as if while you get the final result you will not understand. Suppose one part of the transaction, one piece of uh, one piece of transaction which has multiple, one piece on block which has a multiple transactions are happening side by side same time. So, but when you get the final result, you will as if you'll find that it should be same as if the transactions was executed sequentially. If the transaction would have happened sequentially, then it will be one after the other. So you will feel that is you have got something sequentially, whereas on the contrary, actually what has happened is that these transactions were happening simultaneously, but they must not, and they were not interfering with each other. But when you get the final result, it will seem as if the transactions were executed sequentially. Example: two customers booking the last seat of flight should not be able to confirm at the same time. One transaction must complete before the other transaction is allowed to proceed. Understood? Like, I am booking a flight ticket, and you are also simultaneously at the same time you are also trying to book the same flight ticket, and there's one only there. So until unless I finish, if I have started little earlier than you, until unless I finish, you cannot get into that. So one transaction must complete before the other transaction is allowed to proceed. So this is isolation. And durability means permanent change. Once the transaction committed in the database, it is permanently stored even if the system crashes. Changes are recorded in non-volatile storage like disk, logs, backup. So I was telling you, know, if HANA would not have had a database, then it would not be called as a database. HANA is a in-memory computing engine which processes data very fast, uses column store, and also supports row store, uh, but mainly focuses on column store, and it's online transaction processing and online processing, both transaction and analytics happening the same machine, same HANA system. And HANA system has the development server and uh, tier, which we call the index server. The database part we call it index server, and development we call access server. And there, this is the HANA system basically. So there are lot of other components which the next diagram will show. But we are now studying the properties of the HANA database, which is atomicity, all captured here: atomicity, consistency, isolation we discussed, then durability, permanent change. Once the transaction is committed, it is permanently stored even if the system crashes. Changes are recorded in non-volatile storage, the disk, logs, backups, and after the pricing and online order, even if the server crashes, the order remains in the system due to durability. So why is ACID important? It ensures, okay, first let me show you the diagram. Hmm. Highly simplified architectural overview of the system of SAP HANA. Two server components in SAP HANA system. The database management is index server, as I told you, and most components of the development platform reside in the access server, which is development happening inside HANA. So in the access using Sybase, not ABAP here. This development is to develop the HANA system, the development that is required. That is inside. That is access server. So from the HANA Studio, there's one thing called HANA Studio, another is HANA Client. So client machine logs into the HANA Studio and start building the database internal nitty-gritties, and that it goes to access server. So if you see this diagram, it would be more prudent to discuss on showing the diagram first. You see, this is a simple structure it is showing. First, the simple structure, the network layer 1 or 10 gigabyte of Ethernet. So data processing layer, primary data storage is RAM. So in-memory computing is happening here. It has column table, row table both. It patronizes more on column search and also, but doesn't say no to row search also. So both happens together. You see the processor. So this is the application layer, data processing layer, as you see. Just like in school days, we heard for central processing unit. Then when we were reading HANA, the three-tier architecture, R3, we had a presentation, application, and database layer. Similarly, in the HANA server, we have this data processing layer or the main memory and CPU. This is where we have the RAM. So in-memory computing is because of this, but it also has this layer, which is a persistence layer, where we have the data disk, typically from storage area network or DAS, SAN or DAS. So this is data, and there are multiple log tables. The log disk, they're either SSD or NAS. So this is the persistence layer. So from here, uh, these two layers are connected like this, and the external storage is also here. Typically some NAS or NFS. Data log backup is here. So this is external storage and this is in the persistence layer. So why don't we first find out through the definitions. Okay, let us read what is access server. I was talking about development in Sybase, using Sybase, right? So access server and the SAP web dispatcher. SAP web browser, SAP web browser apps and admin development, HTTP request access server. Since the beginning, but especially since SPS 5 release, SAP HANA has been a development platform built around the integrated database kernel. So it's a development platform built around the integrated database kernel, the HANA system. Access server is here, index server is, these are all in one place. Uh, where it is? Yeah. The access server, which was introduced in Support Pack Stack 5, targets the development layer on the top of these rather technical tools. So it targets the development layer, okay? Access server. This is targeting the development layer. So among the features provided by Access Server are server-side JavaScript, OData services, and XMLA. These you will terms and technology will understand if you have done HTML5 or JavaScript and you build web pages. So these things, so server-side JavaScript, OData services XMLA, development of user interface is using HTML5, very good, with SAP UI5. Development of user interfaces, HTML5 and SAP UI5 both are getting used. Application and definitions to expose sets of development artifacts as application. So application created in SAP HANA Access Server are exposed through HTTP request. So SAP HANA Access Server, see this line, HTTP request. Web browser to Access Server, HTTP request. As a web server component, SAP HANA uses SAP Web Dispatcher. So in normal R3 also we heard something called dispatcher. We know it, right? This is there in the application layer. So dispatcher dispatches the request coming from the user to the next available free work process like dialog, update, enqueue, background, message, gateway, spool. So if it's a dialog request, it is an interactive request, let's say. But if the dialog word processor is full, it will wait. And once the dialog word processor frees up, the next thing in pipeline will go to that dialog. Otherwise, it will move to the other dialog processors. So this is the basic of SAP which we know. In HANA also something similar. So there is in Access Server, there is SAP Web Dispatcher. So SAP Web and it flows through HTTP request. So SAP web browser, this is HTTP request. Applications created in HANA Access server are exposed through HTTP as a web server component. It is always telling web browser, web server, every time web browser, end user, application, HTTP is request coming via end user through the client applications, or in the administration or development tools also you have web browser like this. So uh, this is for SAP Web Dispatcher, which will well known to all SAP NetWeaver. Yeah, so we just explain like SAP Web Dispatcher. So there is something called compile server. The next thing. So where is the compile server? Do we have it here in this diagram? Mm, no, compile server. While the release of SAP HANA Support Pack Stack 6 Revision 60, the compiling of L script procedures has been moved from the index server process into the newly established compile server process. This is a mandatory automatically installed component of the SAP HANA that is in our experience you not need to know very much about it from an admin point of view, but that's why they have not further elaborated, but they're saying there is a compile server. Then it is with the release of SAP HANA SPS 6, the compiling of L script. Compile server is used for compiling the scripting language script procedure has been moved from index server process into the newly established compile server process. So earlier it was getting processed inside the index server, but now it has moved to compile server. That's all we need to remember. Now we need to understand what is preprocessor. This is for processing unstructured data. SAP HANA's preprocessor component creates searchable full text index and offer capabilities such as tokenization, tokenization, streaming, and extraction processing. It might be regarded as a supporting component for index server for text search and text analysis. Unstructured data. There are two type of data mainly: structured data, unstructured data. So in big data concept, Hadoop, then if you think about data lake, in, in data lake comprising of all the data volumes that are coming and getting stored inside it. Some are structured, majority is unstructured. Then from there you have to extract, then you have to transform it as per your requirement and load it back. ETL tool. So there are different ETL tools, POBJ, BODS, those things are there. So it is what it's saying, preprocessor. For processing unstructured data, SAP HANA's preprocessor component creates searchable full text index. So index, what I can say, let's say you take a book. So if the size is little overwhelming, right? And you necessarily don't have to read everything. But what you do is you read the contents and things first. Then you see something called index, which is at the end of the book. Contents at the somewhere beginning, indexes at the end. So in the indexes you will see the uh, page number. Normally in engineering college, what we have done, or even in school time also, we will tally the syllabus with the index and we'll find the page number. We'll go to the page number, capture the definition, put it in one place, stack it all, and then once you understand that, side by side you start reading the chapter end to end. Then those two things will correlate. So I am also following a similar feature here because we are trying to grab the essence of the knowledge on our discussion. We are not trying to mm, we are not trying to memorize it, neither we are trying to do it beforehand and then coming here, because I am explaining as is. What I'm seeing, I'm explaining. I have read this portion sometime, but there are many places in different books that I will be referring. I would be just like you, I would have also read it for the first time. But the approach is take the main points and then analyze and get the understanding synopsis out of it. And that understanding you kind of keep it in your brain so that you can relate. Like preprocessor is for what? It's a component which creates searchable full text, indexes, and offer capabilities such as now tokenization, normalcy. These are database concepts: tokenization, normalcy, or sorry, normalization, streaming, and extraction process. So we should quickly ask the dictionary, or say in this case ChatGPT, what is token, ZATION? By tokenization, I mean what? Indexes, some tokens, some pointers which will point there. So but exact definition, what is tokenization? Tokenization is a data security technique that replaces sensitive data with non-sensitive equivalent called token, okay, while keeping the original data safe. Okay, yeah, understood. Now remember, actual sensitive data is stored securely in a token vault and can only be retrieved with authorization. So tokenization is a data security technique that replaces sensitive data with non-sensitive equivalent. Some sensitive business data, you don't want to get it impacted by any of the transaction request, but you will take an image of it. Tokenization. So that particular pointer will hit that particular image, and what the user or what the query person who's doing the query will see, the non-sensitive part of it coming on the coming as a result, but the sensitive actual uh, data is left in the token vault and can only be retrieved if that person, he or she, has the necessary admin level authorization to go inside it and fetch the real data. So it's not, so we are not touching the real data, we are touching the what to say, we are touching the tokenized data, which is the non-sensitive part of the data, the image of the data, which is not having the thing is the entirety. The actual sensitive part is will be omitted, and non-sensitive part which will come in display will come in display, and the sensitive part, that value, it will remain inside stored securely in a token vault and can only be retrieved by authorization. Now, bottom things will be clear. Input data, sensitive information. When you're trying to input, let's say credit card number, best example, it's a sensitive information. Tokenization process. This data is replaced with a random token, right? A1, like this, A1, B2, C3. Token storage. Original data is securely stored in token vault. No one is able to touch. 4111 star 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 1111. So it is saved. Like when you are putting credit card number, you will see sometimes in some places you will see uh, stars are coming, so that even while putting you are not able to see it, and just below that we have to type in the whole number, that time you put it. But this sensitive data is stored in token vault. In the using the tokenization process, the data is replaced with random token. So this data is replaced by this random token, and next time it will, again, if you log out and again try to search, it will generate another random token based on the concept of probability. So token storage, the original data is securely stored in the token vault. Token usage, the token can be used in transactions, but it has no value outside the system. So during the course of transaction, like PayPal or any Google Pay or anything, during that phase when you are doing the transaction, you can, this data is getting used, the tokenized data. But outside the system, it has got no value. So detokenization, if needed, if you have to pull the sensitive data also, only authorized systems can retrieve original data using the token. Like credit card processing, healthcare records, SAP system tokenization. So these are the sensitive data where the payment system replaces the real card number with a token, that is credit card. Patient identifiers are replaced with tokens to protect sensitive medical data, medical history, everything. These are sensitive information. We do companies need to be comply with GDPR Act. If it is if the industry is operating in Europe, then GDPR Act, or even if the industry is operating for other continents but have UK or rather Europe specific data, then they have to be GDPR compliant, mm, like this. That is another topic, but I just gave you the heads up. So tokenization, streaming, and extraction process. It might be regarded as a supporting component to the index server for text search and text analysis. So this preprocessor, now as the time comes to see the, okay, I will show you the whole diagram. First, let us understand the concept. So tokenization, it can be used for text search and text analysis. Where is the diagram? Here. This was the diagram I was trying to refer. This is the complete diagram. See, web dispatcher. Now it will be pretty clear to you when we discuss. Database client, HTML or XML request going to the SAP web dispatcher, which has a HTTP server. From there, it is going to the XS server, which is the development box over here. Now, it takes care of the development of the HANA console, the HANA itself, the development of that part. So what does it have? It has a session manager which establishes a session with the with that processing that is happening. It establishes session. In order to establish the session, there has to be authorization. So we have authentication, not authorize, authentication. Similar, you have to first your ID should be authenticated. Then only you can get into and create the session for yourself. There are resource handlers which handles OData, static component, C++, JavaScript runtime. These things are there. And there is a job scheduler. Okay, I have a doubt because as far as I remember, Access server uses uh, Sybase. But as far as what we are seeing here is the Access server have OData, orchestration data, static components, C++, JavaScript runtime. So what is the programming language used in SAP HANA XS server, used by, not in by, SAP HANA XS server, and what does it develops? HANA Access means extended service. So extended service. This server primarily use JavaScript, SQL script for development, not Sybase. I am wrong. I was wrong. JavaScript and SQL script for development. JavaScript is uses server-side logic in SAP HANA Access application, server-side logic. And SQL script is used for database procedure functions and optimized data processing in SAP HANA. Okay, orchestration data service, SAP HANA Access server expresses data via OData based RESTful API, uh, application programming interface using JavaScript. So basically, it is using either JavaScript or SQL script is all we had to know, and it is used for database procedure function and optimized data processing. This is what it is basically building out of it. Like SAP HANA Access server is lightweight built-in application server that allows developers to build full stack application Right now, you know the full stack developer, right? They work end to end. They're not on a particular specific area. They know it end to end. So web-based application, RESTful API, business logic, embedded analytics, all these things are coming. Like web-based application, they are using UI5 or Fiori app and dashboard with JavaScript and OData. Developing either SAP UI5 or Fiori apps they are using. They are making those boxes, the slides, and the screen is filled with those boxes where you have to go and put the data. I mean, sorry, not put the data, where you have to click to fetch the contents inside it. And the dashboard is built using JavaScript and OData. RESTful API OData service creating web services. Business logic data processing executing SQL script. Embedded analytics running analytics report. Real-time processing within SAP HANA. So all these things, C OData, static content, C++, JavaScript runtime, all this is showing in this diagram. Below this, we have the job scheduler, and below that, we have the index server inheritance, which is having persistence layer and SQL execution. Now, what we have seen here in this other book, one second, let us now minimize ChatGPT. Always try to think as much as you can, self think by reading the book and get extrapolate the meaning out of it. If you are stuck, then you can go to Wikipedia, ChatGPT, wherever to find that particular portion of it. Otherwise, majority of the things we can understand through the book, but ChatGPT is no doubt a helpful tool, so that can be candidly used as per requirement. But if you refer 2 3 books, but it is little time taking, but it will, that knowledge will sustain for longer duration. In fact, if you read books, and in technical world, we actually skim through the books as a basis administrator install. I found that very difficult for me, because when it comes to skimming the book, I am I can skim the book, but I don't feel the happiness out of it. So if you really have to be happy, what I feel is you need to have the tenacity to read first 5 6 chapters at least of that book, uh, end to end. Remaining 5 6 chapters will take very less time if you are able to cover up the first 2 chapters. First 2 chapters is very important for almost any book. That is where you get the majority of information. 2 to 3 chapters. And while I was talking to you, it lost this. So persistence architecture, in-memory computing studio, administration, modeling, load controller, yes, ERP database. This is another diagram. In-memory computing engine, SQL process. Okay, why not read it a bit from here? Let us read these 2 pages. The SAP in-memory computing engine, formerly business analytic engine. Okay, earlier it was called business analytic engine, is the core engine of the SAP's next generation high performance, okay, in memory solutions. We discussed it a number of times. In memory solution, high performance. This is able to leverage technologies such as in memory computing, columnar database, massively parallel processing. Massively parallel processing. Just a while ago, I was discussing parallel processing. So it is what is IMCE, which is in-memory computing engine. IMC is nothing but HANA's in-memory computing engine it is referring to. Earlier it was called business analytic engine. Okay. And data compression to allow organization to instantly explore and analyze large volume of transaction and analytical data across the enterprise in real time. Absolutely self-explanatory. We can simply take it, and for our future studies, we can put it here. Can dump it here or directly, or let us dump it in the Word document first. And since we have captured this whole part, why don't we highlight it also? Okay. In-memory computing allows processing of massive quantities of real-time data in the main memory of the server, okay, providing immediate results from the analysis and transaction. The SAP in-memory computing database delivers the following capabilities, which is what we discussed just a while ago: ACID, atomicity, consistency, isolation, and durability. The in-memory computing functionality with native support of row and columnar data stores. See this. It is not saying it doesn't support row. It do support row, but columnar is what it prefers. Row and columnar data stores providing full ACID, which is atomicity, consistency, isolation, and durability. Integrated lifecycle management capabilities and data integration capabilities to access SAP and non-SAP data source. So you can access both SAP as well as non-SAP data source. And SAP IMCE Studio that include tools for data modeling, data and lifecycle management, and data security. This kind of modeling is what it do. Data and lifecycle management, data security. So in-memory computing engine, two-part: in-memory computing, calculation and planning engine, data management service. The SAP IMCE that resides on the heart of SAP HANA is an integrated database and calculation layer that allows the processing of massive quantity of real-time data in the main memory to provide immediate results from the analysis and transactions. Online transaction protocol. One is online transaction processing, one is online analytic, OLAP, analytic processing. So OLTP is what it is discussing over here. Massive quantities of real-time data in the main memory and provide immediate results of the analysis of the transaction. So this is an important line. We will take it from here. Sorry, it's getting stuck. One second. Yeah, now it is fine. And we will dump it into our Word repository, which is here. Like any standard database, the SAP IMCE not only supports industry standards such as SQL and MDX, but also incorporates high performance calculation engine that embeds procedural language support directly into the database kernel. Procedural language like SQL directly into the database kernel. This approach of design designed to remove the need of from the database, read data from the database, process it, and then write data back to the database. That is, process the data near the database and return the result. Very good. What it is saying is that SAP in-memory computing engine, it not only supports the industry standards such as SQL and MDX, but also incorporates high performance calculation engine that embeds procedural language. Procedural language is C. C++ is, I think, procedural language. We read it in college days. Is we are correct, right? Whenever you have a doubt, just check. Procedural language examples. It's a step-by-step approach, procedure, also called transactions and routine, to perform tasks. These languages emphasize structured programming where logic is executed in sequence of command. Okay. Example: C, C++, Java, Python, SQL, PLSQL, PLSQL, Pascal, Fortran, Basis, COBOL, Perl. It supports all these things. So what it is saying now, the SAP in-memory computing engine not only supports industry standards such as SQL and MDX, which are industry standards. Apart from these procedural languages, other procedural languages like C, C++, and all the Perl, Python, PHP. Uh, it supports every bit of the things here, but also incorporates high performance calculation engine that embeds procedural क्या करता है sorry what is done embeds procedural language support directly into the database kernel. Procedural language support directly into the database kernel. This approach is designed to remove the need of read data from the database, process it, and then write data back to the database. So read write, that big chunk of activity is reduced. Procedural language if is embedded with SAP in-memory computing engine, which is our HANA, and it embeds procedural languages support directly to the database kernel. You can directly inject the medicine inside the heart of the patient, or you can, in what I mean to say, you can directly put it in the database kernel using embedded procedural languages. The in-memory computing engine is an in-memory column-oriented database technology. It is powerful calculation engine, which is the heart of HANA. Data resides in random access memory RAM. Highly accelerated performance can be achieved compared to system that read data from the disk. You have to go to the disk. The disk will be like this, and there are pointers on top of. You have seen hard disk from inside. I've seen it once. Like it's a CD, just like a CD. We have no multiple of this, and there are tracker. So it can either read from like this, no, like this. Okay, why don't I show you something? Although we are little digressing from our core topic, if I do, but it is important. Hard disk drive uh, internal structure of hard disk drive, and then I go to the images. See, you are already seeing the images. See, database is also stored in 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 this kind of way only. See this pointer, this pointers, it will read from here, or it can read from the bottom tier of the CD, or it can go to the core of it. Hmm. If you see this diagram, and if you try to maximize it, verifying that you are a human. This may verification. Okay. Base casting, cover mounting holes, case mounting holes. This is a see. There's so many reading pointers. These are called platers. So it will, when this is rotating in a high speed, you read it from either this section or that section. So if the data is stored here and it is searching columnar way, it will directly pull it from there. But what they are trying to say is, instead of loading the data, and in earlier days how we used to happen, that it will read the data from the database, process it, and then write the data back to the database. So this is not needed anymore, because the in-memory computing engine can embed procedural language support directly into the database level. Uh, Random access memory. The heart lies in IMC, in-memory computing engine, which allows us to perform calculation on the data only. We calculate immediately and immediately give the result from the RAM. We will do the processing. We will not go to the ROM. So SAP IMC Studio includes tools like data modeling activities, data and lifecycle management, and also tools that are related to data security. All these things is there. Okay, the following diagram shows architecture of HANA, including in-memory computing engine and how it is connected. Data volume, data storage, persistence layer, logger, page, in-memory computing engine is this whole thing. We have the SQL parser, SQL script, MDX, and calculation engine. We have the relational database. We have transaction manager, authorization manager, metadata. Metadata, what you know, data about data. So that is also there. We have a replication server. And if we go through their definitions, and this is they are only focusing on in-memory computing engine this time. Over there in the previous diagram, they have focused on the entirety SAP business object, other sources, client, these all things they have discussed. Oh, sorry. So this whole thing they have discussed. And what you have here basically is in-memory computing engine. The HANA database, the HANA database has the following two engine: column-based store, row-based store. Now we'll go a little fast. The engine stores the huge amount of RDBMS, session column optimized table, which are aggregated and used in analytical operation. Analytical operation column-based store is used. Okay, row-based store. This engine support relational data in rows, similar to storage mechanism of traditional database system. Traditionally, as at earlier days, it was like this only. That is, earlier days we have to first put the data, the system will have to read it, then bring the inference, and then come back, which is written here. Allow to create and perform calculations in data. SAP includes tools and data modeling activity, data and data life cycle. So it embeds the procedural language. This approach is designed to remove the read data from database, process it, and then write data back to the database. This whole thing is now removed in in-memory computing. It You can do the work directly inside the database kernel itself. Session management, transaction manager. What is session management? Persistence layer is responsible for durability and atomicity transaction. The persistent layer ensures the database is restored in the most recent committed state. So let us, if you read it, it is very simple. It says persistence layer is responsible for durability and atomicity, okay, of transaction, okay. The persistence layer ensures that the database is restored to the most recent committed state after restart. In case crash down after restart, database will return to there is checkpoints, right? So the last checkpoint just prior to when it crashed, it ensures that it at least goes up to that, restores up to that, to where it crashed, just one step before that, up to where it is recorded. So persistence layer uses combination of write ahead logs, shadow paging, save points. Moreover, the persistence layer also offer interfaces for writing and reading data. It also contains SAP HANA's logger and manages transaction log. Authorization manager, it is invoked in HANA database component to check the required privilege for users to execute requested operation. That is authorization manager. So have I taken that diagram here? Uh, Index preprocessor, name server, persistence, where I saw persistence. Yeah, persistence layer, page management and login. Then data storage is happening here. Okay. Storing data, row storage. Now it will discuss in elaborate row storage, persistence, uh, RAM. The row stores data in row, and in this respect, it behaves as a traditional database. Okay, except that the data always resides in RAM. The row store engine is highly optimized to write operation and is interfaced from the calculation execution layer. All the operations on the row table will be processed by row engine. Okay, so here it is showing row store. It is here where they are trying to explain how when it crashes, how persistence there tries to bring the it to the last safe point. That is explained. Transactional persistence layer, log, redo log file. During recovery, the system cannot find the log offset. Log area, we see error message log and data must be compatible. Error situation, we must use clear log. So it is detailing it out further detail. Index, each row store table, this is important. Index, each row store table is a primary index, row ID and a number of, this specifies the memory segment and the page of the record. Primary index maps primary table and row ID. Okay. Storing data, text retrieval and extraction. Data will be stored in RAM, similar to the row store engine. The the concept of the concept of column storage has emerged from text retrieval and extraction, TREX. TREX you heard, right? In many projects, I think you have will hear this word TREX, text retrieval and extraction. This technology was further developed into full relational column-based data store. Compression works well in column and can speed up operation on columns with a factor of 10. Column storage is optimized, high performance, read operation. These are the two types of indices in column storage. Fine. One moment. Calculation engine, SQL processor, column store, sorry, executor, OLAP optimizer, further down, how the delta merge is happening, write operation, bidirectional delta, read operation from the main, merge operation, main 2, delta 1, delta 2, like this, write operations, main, read operation, delta, write operation. Okay. This is too much in detail. If we have to go that detail, we will be digressing from our main area of discussion of the architecture part. So I'll try to retrieve back to where we were living before. SAP HANA's persistence layer manages logging of all transactions in order to provide standard backup and restore function. Both row store and column store interact with the persistence layer. It offers regular save point and also logging all the database transaction since the last save point. That's all. This is what is persistence layer. This is what we need. The persistence layer is a durability, atomicity transaction. Okay. All the storage, blah blah blah. Provide interfaces, read and write, MaxDB, traditional relational database. Okay, but if you, oops, one second. If you can capture this much, you have understood what is persistence layer. So we'll take it here and we will go and put it here. Mm, yes. Okay, done. See here, data save point, log written to persistent storage, committed transaction, power failure. At least up to this, you can get back once the power restarts. That's what they are trying to explain. Further reading, HANA appliances, disaster recovery. Okay, from this book, I think we have covered. There are some definitions. Uh, yes, those definitions are here. Again, let's recapitulate few we read other day, few which we need to read again. Index server, this server holds the actual data and engine to the processing data when SQL and MDX files fired against the SAP HANA system. In case of authenticated sessions and transaction, an index server takes care of these commands and processes them. So this server holds the actual data and engines for processing the data when SQL and MDX are fired against the SAP HANA system. So for database, it actually holds the data for the time being when the processing is happening in RAM. The name server, this server holds complete information about the system landscape. Name server is responsible for the topology of SAP HANA system. So it holds the complete information about the system landscape. Dev, quality, pre-prod, prod, or if it is n plus 1 landscape, development quality, pre-prod, prod, and below development quality, the project landscape will end there till the time before the cutover. At the time of cutover, the prod box will be attached with the dev quality and pre-prod and that layer, the, the bottom layer, and then you will that use a phenomena concept of retrofit, and you will move stuff in a global uh, landscape in a global rollout so that mm, the next time the bottom tier becomes a maintenance landscape, and if new project n plus one landscape, the next project environment is the next geography in which it is traveling. So those are n plus one. Name server, the server holds complete information about the system landscape. Name server is responsible for the topology of SAP HANA system. So it contains the all the name nomenclatures topology about the entire SAP system is name server. Preprocessor server, this server comes into the picture during text data analysis. Index server utilizes the capability of preprocessor server in text data analysis and searching. This helps to extract information on which text search capabilities are based. So it is for text data searching, preprocessor server. And what we persistence layer, that is another thing. Statistics server, it holds and collect data, system monitor and help you know SAP HANA system. Statistics server is responsible for collecting the data related to status, resource allocation, consumption, and performance of HANA system. So it serves helps what it does, it collect data for the system monitor and helps you know the health of SAP HANA system. Statistically, it will analyze the HANA system. Then engine is external application, external application developer and access the SAP HANA system via XS engine client. For example, web browser accesses SAP HANA app, built an application developer by HTTP. Application developer built application by using the XS engine, which I was explaining when I was showing you this diagram, just a while ago. I was explaining, right, how this will flow. The same is showing. Access engine allows external application and application developer to access the HANA system. Application developer external to that to access the HANA system hmm, via access engine client. Okay. For example, a web browser accesses SAP HANA apps. Web browser accesses a SAP HANA app. Okay. SAP HANA built-in application developer via HTTP. SAP HANA apps built by application developers via HTTP Hypertext Transmit Protocol. Application developers build application by using XS engine. and the users access the app via HTTP using web browser. So user will access it in web browser, and application developers will build application by using access engine. The persistence model of SAP HANA database converted into consumption model for client access via HTTP. This allows, for example, search service built in web server and provides access to static content of the repository via web browser. Up to this is important. Access engine. Okay. Basically, that's it on HANA administration, HANA architecture. I mean, I think we have discussed from couple of books here, and if I take you to the HANA cook, no, this is not the HANA, this is the HANA cook, not this one. If I take you to, um, okay, this one we will see. Where is my, wait a second, I'm just trying to find that book where it has gone. Okay, meanwhile, this book is also very good. This literature, it talks about introducing to SAP HANA, HANA technology, daily iteration, daily, not iteration, daily what? Uh, Daily irritations. Existing technology was not designed for modern challenge and use case as shown in daily iteration figure. Suboptimal. This is like hardware technology, SAP software technology, multi-core architecture, 64-bit, no aggregate, insert only the data, in-memory computing we discussed, fast data disk, fast low latency, SAP HANA design, OLAP, data visualization, text analysis, search, geospatial, geospatial graph, web. So SAP also added engines inside SAP HANA to provide the following features. You see, SAP has added so many engines inside SAP HANA. And what does they do? Virtual online analytic processing, OLAP, I was discussing analytic processing, data virtualize, text analysis, search, geospatial maps, graph, web, lot of things. Row versus column stored table, DRAM. Table A has row table, DRAM. A and C table A, okay. SAP HANA deployment option can be single host configuration, or SAP HANA has a host and this is also as a host, single host and multi-host. Two-way you can deploy single host system or multi-host system. In single host system delivers SAP HANA features and performance capability but has no high availability features. High availability, I was telling you, yesterday, node toggling. If one node goes down, toggle to the other one. Install SAP HANA system as a multi-host system using multiple compute node and more standby nodes. So let us take this picture and try to see what we get out of it. These are in addition to the HANA architecture. This is something further detailing out that HANA deployment option is further detailing out the things. But I find this diagram interesting. Sorry. Mm. Enables remote start and stop, SAP host agent. Manages SAP software update, SAP HANA Lifecycle Manager. Master name server, master index server, XSS server. Name server, and this is on multiple hosts. This is one single host configuration. Multiple hosts, you will have name server and index server in the SAP HANA database and host agent below. And you will another C name server, index server here, host agent below. Node 2 to node n, node n, multiple nodes. But if you talk about only a single host, it's SAP HANA host, SAP HANA database, master name server, master index server, XSS server, SAP host agent, SAP lifecycle management, and this is in node 1. Okay. So now let us see this other book which I was referring. It got closed accidentally, or is it still there? No, it has got closed. So let us open it fast. SAP HANA admin 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 mm-hmm. mm Administration. This is the one. Oh no, sorry, not this one. What was the name of the book? Not this one. SAP HANA. Mm, I'm forgetting the name of that book. SAP HANA Administration. Oh, one is Administration, another is SAP HANA Administration. Yeah, I was searching like SAP HANA Administration. Sorry to keep you guys on hold. I'm just trying to find their book. SAP HANA. Oh, this is the same book. First one. Wait a second. I'm searching it out. Just quickly open it. SAP HANA Administration. We were almost there on the verge of ending SAP HANA architecture from the SAP HANA administration book. Book is there in my system also. No, no. I found it from here. It got closed somehow. SAP HANA administration. Here then SAP HANA administration. Yes, this is the one. Yeah, this is the one. So over here we have covered these diagrams. Access server and SAP web dispatcher. Just now we were discussing on that since the beginning, but especially since SPS5, SAP HANA has been a development platform built around the integrated database kernel. Of course, the database itself, that is index server, offered development capability such as designing the database schema, views, and SAP HANA data model or stored procedure. The access server, what kind of development is done? Index server does the above things, as you see: database schema, views, these kind of development will allow. But access server, which is introduced with SPS support pack stack 5, target the development layer of on top of these rather technical tools. So among the features provided by access server, we have JavaScript, XML, HTML5. These all we discussed. Statistics server, we discussed that starts SPS 7. It is possible to have statistics service integrated on index server. The name server process, uh, thus eliminating the need for the dedicated database. Okay, one moment. Need for the dedicated database. The database process which provides statistics service start with support pack stack 7 revision 70. It is possible to have statistics service integrated into index server, which is a database component. Statistics service added to that, and script server, SAP HANA auxiliary processes, HANA lifecycle manager. We were just referring to support update to the main topic of HANA lifecycle HLM, which is a graphical application that supports updating just the database of all the components. So called SAP HANA support package stack. By using corresponding components installed in the database server, the front-end application is available from within the administration tool of SAP HANA Studio. Okay. HANA Lifecycle Management functionality extends beyond updating with support from system landscape modification. These things are extra jargons to that we don't need. Host agent. In this diagram we discussed, and is this diagram also captured here? Okay, no, never mind. Persistence layer, page management, logger, statistics. Transaction manager in combination with persistence layer. Transaction manager is also responsible for achieving atomic and durable transactions. So Interface between in-memory store and the data volume on disk is implemented by the persistence layer. This component manages the data pages for the in-memory stores and their persistence into the data volume. It also controls the writing of the transaction log entries to the log volumes as per that diagram. So index server, persistence on master, persistence on slave, distributed persistence, name server, access server, preprocessor. So we basically are now good with where persistence layer is. It is here in the data processing. So we have discussed these points. Statistics server, HDB tool, hosted then. Transaction manager informs. Okay. But that book's definition was better, no? On persistence layer. Wait a second. The persistence layer, let's take this definition, it's a better one, is responsible for durability and atomicity of transaction. The persistence layer ensures that the database is restored to the most current committed state after the restart and makes it sure that the transactions are either completely executed or completely rolled back. To achieve this an efficient way, persistence layer uses combination of write ahead log, shadow paging, and save point. Moreover, the persistence layer also offers interfaces for writing and reading data. It also contains SAP HANA's logger and manages transactional logs. So many things it does. But the main thing that it do is if there is a shutdown or uh, a break in while processing, if it breaks down, then on restart it can bring the server back to the last save point. That is the role of persistence there. So with this we have conclude the discussion of SAP HANA architecture. Rest detailed study you can do the first chapter from this S4 this SAP Press Book, and along with that the associated Press Book together. In Associated Press Book, I think it was the second chapter, and in SAP Press Book, it's the first chapter. So you can do further detailed analysis if required. You can refer to that. But almost our discussions are mostly detailed. In some places, I have rushed for the interest of time, and in some places, I struggled to get the information in one or the other places, which we have taken the necessary help from Google or ChatGPT or in order to streamline our conversation. Because why I struggle is it's a real time session, no? So kind of understanding and giving the aspect at the same time. So but eventually if we now stop the recording, it's 1 hour 38 minutes. It's done. Just checking the average handling time of this discussion is 0100 no sorry 013800. So this one video has made the average handling time 1 hour 3 minutes. So which means anyway we have to stop it first. We will go here. This book is done. SAP Press HANA book. So 26 we discussed, and today is 2nd of March. Rather it was no. You moved SAP Press HANA to finish on a non-working day. Yes, Sunday 2nd March. Sunday 2nd March, make it a working day. You see, the MPP gives you the option. Remove SAP Press Book HANA previous work day. Allow Press Book on SAP HANA to finish in not make the Sunday zero. So allow SAP Press Book on HANA administration to finish in a non-working day. Make Sunday 2nd March 25 as a working day. Either of this will do. Let me make the first one, no problem. So we started it basically Friday, yes, Sunday, and what is the percentage we have completed? 100%. This is done. SAP HANA Cookbook. This also we finished here, which is fine. It is still okay. And time consuming is 100%. Okay. This these two areas we have touched on SAP HANA architecture. It is okay. So HANA architecture is done. Further reading recommended. Next, tomorrow I will either start with tomorrow I will start with S4 HANA first. S4 HANA introduction and S4 HANA architecture. So with this I close this tutorial for now. Happy learning. So I have to keep it as a one single tutorial of 1 hour 38 odd minutes, so that in the one place only you will get everything rather than breaking it up. So that should be fine. Okay, so I am shutting down the session. Have a nice evening. Thank you.